One has to see what Indian standard says and what are the effect of water other than mixing. Even for curing also need to be water to be tested. So concrete is produced by mixing binding material and inert material with water. Binding material is your cementitious system. Inert material your aggregate. Around 99% your aggregates are inert in the nature, and then with water. Water and binding material, they are reacting. So water and its quality is very, very important. Also quantity, that will come to later. But quality of water plays an important role to determine the quality of concrete. Because most of the site we have seen that water is rarely testing. Because you don't get water from corporation. Corporation water is already treated, hence it is not required to be tested. But water which is coming from other source than corporation need to be tested. So it is very important role of quality concrete. So strength and durability is a large extent determined by the water to cementitious ratio. That will come to that water cement ratio when you talk about the fresh properties of the concrete. But once here you have to remember that water is also very important, both quality as well as quantity. Now, why water is required? Generally, when you add cement, water in the cement, it make a paste. And that paste is basically covers the all the particles which is available by the fine aggregate to coarse aggregate coated by the cement paste. So that is very, very important. And once that coating is perfect, you'll get very good strengths. And then coating also required to be minimum thickness. We should not have very thick. That's why we are saying you have to use very optimized cement content or optimize water content also. Should not use very dry, should use very wet. So water also decide quantity of water decide on the basic your workability requirements as well as your source of materials. Means right from 150 micron to say 20 mm, we have got various sizes that will cover in aggregates. So all the particles has to be coated with the cement paste or cementitious system paste. For that particular water content is required. So water content is depend upon your workability requirement and also depend upon the grading and shape of your materials. Because shapes decide your surface area of materials. So when surface area is more, you need more water. If surface area is less, you need less water with the same workability. So that you have to remember, and accordingly we have to make adjustment during your production of concrete. Is very, very important. As I said, chemically reacting cement and water helps to produce desired properties of concrete, both in fresh stage as well as in the hardened stage. Now, when you are talking about normal sites where the facilities are not very high, we are working on volume batching. Though we have batching plant in cities or next sub cities or second cities, we can say metropolitan city, and then second cities, all batching plants are available. But where small sites are there, it is very difficult to have a batching plant because quantity is very small. And then we produce by site mix concrete. And where batching is not that importance given. So quality of water is neglected, very highly neglected at the sites. That is our observation, and that affecting your durability of final product. How is affecting? We'll discuss that. So commonly accepted for anything is potable water, means water which is you can drinking purpose can be used for or suitable for your mixing as well as curing. So one thing one have to remember is as a simple taste test, you can drink the water and see whether it is I can drink very easily, because sometimes some salts are there and it gives a different taste which is not suitable for drinking but may be suitable for concrete. So one has to see that the water which is using in concrete has to be as per requirements. Now in my lecture I am giving some IS code number that you need to write down the numbers and go through those codes, because very essential for your when you are going to the site. So these references are very important. Now there is a possibility that a lot of salts or any other material is available which is give adverse effect on the concrete properties, both in the fine aggregate as well as your fresh properties as well as hardened property. Now for pH value they are given a range that I will show you what is the range they are given. And algae is also is to avoid because it may give air entrant in the result term the loss of strength. Whatever air entered into the concrete will lose the strength with certain amount of whatever air is there. Seawater is not allowed for RCC. We can use for PCC, but seawater also having salt and that will give efflorescences on the surfaces. Though it is reduced limited to 15%, but for RCC it is not allowed to use any seawater. And we are seen in Mumbai, lot of project people are whatever available nearby ponds, they are using that water and getting a lot of issues in the concrete because all seawater contain chlorides, and chloride ultimately responsible for corrosion of the steel. And once corrosion started, is very difficult to stop. It's like a cancer for the concrete. We can prolong with the system, whatever system or whatever repairing we can do, but we cannot stop completely. That we have to avoid initially only to see that certain limit as given in IS code. Accordingly, I have to check the water and then only I use for concrete. Otherwise, it's very difficult to repair afterwards. Not possible to go 100% coming to the original position. So thus the chemical constituent present in the water may actively participate in the chemical reaction, and that affects the setting time, hardening process, and staying development of the concrete. So you are always remember all the three effects. And also there is a issue of hardening in the sense initial hardening and setting is refers to your workability requirement also. Sometimes some water will find suddenly it has set without any issue it has set. So that wants to understand. Therefore, it is always better to check water quality for ensuring good quality concrete. Now, question will come: how to test at site this water? Is there any possibility to check? Because water is always do the chemical analysis, and chemical analysis is a very big process. So you have to send water to the laboratories, get the tested. By the time report comes, you have consumed the concrete. So you have to plan properly, and then only we proceed for testing. At least source you get approved. The source of well or water, whatever it is coming, you go there, collect the source personally, or send your representative who can collect the water sample from the source itself. Otherwise, the supplier may play with the sample. That is happening at various sites. So one has to be very careful to go for the proper sample of water. Now, water in concrete, why you need? There is a chemical reaction with cement. and then next is your workability. These two prime requirement for your need your water for concrete. Now, if you see in reality, the hydration process, what we had discussed earlier with the cement, we need hardly 25% water. So water to cement ratio roughly around 0.25 is sufficient to hydrate the entire cement paste, cement particles, whatever available. Now additional water, when you are working at site, we are adding water maybe 0.4, 0.45, 0.5, those ratio. So adding just double the water, then what happens to that water which is not taking in part in the reaction? So that remains in pores or air bubbles in the concrete, hardened concrete, and that is resulting very porous concrete. So porosity is very high, your permeability is very high, will have very bad durability and also strength. Some amount of water is good for plastic shrinkage cracking. When you're discussing about fresh properties, we'll discuss this. That's why we always says water has to be optimum. Even workability is also required to be optimum. You should not have, suppose I want 100 mm slum, I can go 100 plus minus 20. I cannot go 180 or flowable. So that has to be a proper control over the water content. If you have better control over water, because what is happening is cement is coming by bags. So that 150 kg is fixed. There we cannot play. So one bag is 50 kg. Now whatever you are adding water is only by the volume or by weight. So there you adjust your water requirement because cement cannot be changed. If one bag has gone and we know it is 50 kg. So water has to be controlled at optimum content for the required workability. That one has to understand and proceed for concrete production. It's very, very important. Otherwise, you get very high permeable mix, strength is lost, and also you got durability. So basic purpose of having good structure, though you may get the very good strength because today quality of the cement is excellent. So you get the strength, but it is a permeable, then the loss of durability, it will not have sufficient design life of the structure. So we have to always use optimum quantity of water content. This is what we have discussed. Excess water is creating bleeding, basically. It also give very good cohesion if you have optimum water content. If you have excess water, you'll find that aggregate bigger particles are going away from the concrete. It's called segregation. So when you place such concrete in the structural member, what is happening is you get aggregate one location and cement paste at the one location. Very thick layer of cement paste. That's called segregation, and we'll have different component in the same column, suppose column or beam, whatever is there. So bottom will have only aggregate, top will have only paste. Then distribution traces will be different. So we have to avoid segregation and excess water or excessive bleeding. Bleeding we'll discuss in fresh properties, what is really bleeding, what are the tests for bleeding, that also we are going to. So optimum water use for better quality of concrete provided it can consolidate it properly. Optimum in the sense, whatever concrete you produce, you should have a proper workability that you can transport, place, compact properly. Otherwise, we will get very harsh mix or very stiff mix, which is difficult to vibrate and then better compaction. Ultimate aim in the structure, we should have a proper compaction near to the theoretical density of the concrete should be achieved. So depend upon the vibration capacity you have, accordingly I can decide what workability I need. Also, concrete has to be pumped because now around 90% concrete in Mumbai or any major site which is coming from RMC, we are doing by pumping. So pumping also required certain amount of flow or slump. So that we have to keep in mind, and accordingly we have to adjust the water and admixture dosage. Then only it is possible to get proper concrete in the structure. Now, what are the impurities in this? Interference in the hydration of cement. One is your organic matters, and then chlorides and the sugars. Now, sugars always give a delay in setting. Your normal sugar also, if you add in concrete, you will find concrete is delayed. It will not set for even 24 hours. So sugar is not advisable for having better concrete. Then chlorides, as I said, chloride also give a effect on your durability, as well as chloride is also very good accelerators. Suppose I have to accelerate the concrete setting, you have to make early strength, we can add chlorides. But that is in plain concrete. If RCC is there, so we cannot use chloride based accelerators. So in market, lot of accelerators are available, and if you write there's a note written always, these are chloride free accelerators. There's a lot of other accelerators also available. Cheapest accelerator is chloride, means you can add salt, you get early setting, but which is not advisable to use in your RCC structure, reinforced cement concrete. Then your algae formation, clay, silt also is coming from your water. Is also coming, silt and clay coming also from fine aggregate when you are using river sand, but also it is coming from your water. So that also need to be tested. All sewage contamination is there. Now this any salt coming all in coming a staining on concrete, or you get efflorescences. You must have seen some of the concrete outside wall, we can see there is a white patches. So water is coming by capillary, your water is evaporated and salt remain on the surface. That is your chlorides or iron. You can see around brownish stains in concrete. Most of the old structures where corrosion has taken place, your ferric oxide is dissolved and coming on the surface. So it is affecting your durability. That we have to understand very carefully. So this is IS 456. IS 456 for mixing water and curing water. They are given certain limits. Organic matters 200. That is the maximum limit. Inorganic about 3000. Now this code you can, all engineers should have this IS 456 latest version always. Now this is also under revision. Maybe within few months the new revision will, because it is 2000, already 20 years are over now, and we are now changed the concrete drastically for last 10-15 years. So now they are going for the revision of the code, like other codes also they are revised. Now 456 also under revision, now under discussion. So I think slowly it will come. Is basically a code of practice. So all civil engineers should have the copy of IS 456. They're all right from material to design. Everything is included in this. And this is what everybody is following for construction industry. A lot of other codes are there and that we subsequently will know that. But this is one of the very important code. Everybody should have copy of that code. Organic suspended matter, that silt and other things, 2000 is limit. Now in chlorides, see PCC around 2000 is allowed, milligram per liter or ppm, and or RCC is hardly only 500 mg per liter. So you see, this is 1/4 of this. So you have to see that your water always should not cross this limit. It is always less than this. For sulfate, 400, because they may get sulfate attack. As I said, sulfates and aluminates, as in the cement, will react and having calcium sulfoaluminate, and calcium sulfoaluminate is always a form of gel and it swells. Once it swells, it disturbs its structure, means concrete structure, and start cracking. That's why you always use normal OPC, you go with the SRC, sulfate resin cement. Or we can have other combination that we'll discuss during properties of concrete. pH also in between 6 to 8. Now in this measure your parameters to be tested at site is at least chloride, sulfates and pH. Now test this parameter, you need not to send at laboratories, because in laboratory we'll get a week report maybe after 1 week, 10 days. We will not get report immediately. So there is a small kits are available today, water testing kits. Very handy kit. So everybody, all the site, I advise to buy those kits and keep at site to check your chloride, sulfate and pH. If that within the range, then all other will not affect much. So those chlorides kit are available maybe 1,500 to 2,000 rupees, and we can test around 10 to 15 samples for that particular kit. It is available. You can also search on Google and go for it. So it's advised to have that water testing kit, portable water testing kit. You should have at site to check regular sample, and every 3 months or 6 months you send for third party to cross your results. Because that is very essential to have those testing is important. As I said, seawater is not recommended for RCC, but PCC definitely we can go for it. If is unavoidable conditions, you have to make a concrete, you can go for plain cement concrete, not for RCC. So water which is suitable founding for mixing, which is satisfactory for the mixing, can be used for curing also. Because curing also we are making wet concrete, always keeping wet concrete. What is the curing? We'll come to that when you are talking about hardened properties of concrete. So curing has to be maintained the moisture within the body of concrete is required curing. So that water also absorbed by the concrete some amount of water. So you may get a lot of stains on the surface if the water is not suitable for use in concrete. So water for mixing and curing. The water which is suitable for mixing can be used for curing. That means, or tannic acid is there, iron is there, you can see those stains in the concrete. Then we'll understand is there any issue in concrete? Maybe some issue is with your curing water. Because people think curing is only to cure the concrete and they can use any water nearby pond and will found these issues are coming up. Because here in Mumbai, if you dig any pond, will get only seawater because we are very near to the sea.